So, let's talk about a really tough industrial challenge. How do you sort hazardous waste wood, like an old deck that's been treated with chemical preservatives, from perfectly clean wood? Now, the modern answer seems obvious, right? Just build a little scanner you can plug into a smartphone. Point, scan, sort. Done. But it turns out the best solution isn't a new gadget at all.
I mean, it's such a tempting idea, isn't it? We've all got these supercomputers in our pockets. Why can't we just snap on a sensor that gives them, chemical super senses to sniff out hazardous wood? Well, as we're about to see, the reasons this just doesn't work actually reveal a much, much smarter way to solve the problem.
And boom, here's roadblock number 1. And this comes straight from the research. Cost. The kind of scientific-grade sensors you need for this job are, and I'm quoting here, cost prohibitive to slap onto every single collection truck. It's just way too expensive. But you know what? Even if money was no object, there's an even more fundamental physical problem we'd have to deal with.
Right, so this isn't just about the price tag, it's about what's actually possible. The problem goes way deeper than what a standard camera, even the amazing one in your phone, is physically capable of seeing.
This slide, right here, shows you the core of the issue. On the left, you've got some old pressure-treated wood. After years of sitting out in the sun and rain, that classic greenish tint from the copper preservative, it's gone, faded away. And on the right, regular old clean wood that's also been weathered. To your eyes, and more importantly, to a phone's camera, they look basically identical. But one is totally safe, and the other one is still packed with arsenic.
So you can see, this isn't just some minor sorting mistake. It's a huge regulatory nightmare. If you get this wrong, you're letting hazardous contaminants slip into the recycling stream, and that is a massive compliance failure. The stakes are incredibly high, and a simple photo just can't cut it.
Okay, so if putting a super sensor on every truck is off the table, what's the plan B? Well, the 905 Wood Systems answer is really elegant, and it's all about architecture, not gadgets. They call it tiered validation.
So, they split the problem in two. You've got the edge layer, which is what happens out on the truck. It just uses a regular old smartphone with a simple AI to do a quick visual check for the obvious stuff like paint or stains. The goal here is to be fast and cheap. But then you have the hub layer back at the main facility. And this is the complete opposite. It's all about 100% accuracy using the big gun industrial sensors to get the final chemical analysis needed to keep the regulators happy.
Okay, so what exactly is this powerful hardware they've got hiding back at the hub? Let's peek behind the curtain and see the tech that access the system's ultimate source of truth.
First up, we have X-ray fluorescence, or XRF for short. Now this is the heavy hitter. It doesn't just look at the wood, it looks inside the wood, hunting for the specific chemical fingerprints of those nasty preservatives. We're talking heavy metals like arsenic, chromium, and copper. If it finds them, bam, the wood is classified as hazardous. This is the kind of hard scientific proof you need.
And the other piece of this high-tech puzzle is hyperspectral imaging, or NIR. This sensor basically sees the world in a spectrum that's totally invisible to our eyes and to our phones. It can spot unique material signatures and textures that the chemicals leave behind, even on that weathered wood we saw earlier that lost all its color. It's like finding the chemical ghost of the contamination. All right, so we've got the fast, cheap sensor on the road and the powerful, precise sensors back at home base. So how does the system actually use them together? Let's walk through the workflow that keeps everything safe.
This part is just so clever. It's a process they call the risk origin check. When a customer says their load is from a demolition, like an old deck they tore down, the system immediately knows, uh-oh, this is high risk. And here's the brilliant part. It completely ignores the mobile app's visual scan and automatically flags the whole load. It says, nope, this one goes straight to the hub for the full-on scientific screening.
And that's the real genius of it. The system uses smart logistics, not some non-existent miracle gadget, to handle the risk. It simply identifies the loads that are likely to be hazardous based on where they came from and sends them down the right path, completely sidestepping the whole mobile hardware problem.
So let's zoom out for a second and put all the pieces together. Here's a look at the entire sensor deployment strategy.
This table just lays it all out so clearly. On the mobile side, out at the edge, you have a totally standard phone camera, no special USB adapters needed, and the goal is all about speed and keeping costs down. Then, back at the central hub, you've got the industrial strength NIR and XRF sensors, and their only job is to hunt for the chemical signatures needed for regulatory compliance. It's a perfect separation of duties.
And that's really the core takeaway here. The big breakthrough wasn't some tiny new scanner.
The real innovation was designing a smarter system. A system that centralizes the really powerful, expensive hardware exactly where it needs to be, and then uses an intelligent workflow to make sure the high-risk stuff gets delivered right to its doorstep.
So it kind of leaves us with a bigger question to chew on, doesn't it? As technology gets more and more complex, is the ultimate goal to just cram every single feature imaginable into our personal devices? Or is the truly smarter path to design these elegant, tiered systems that use the right tool for the right job in exactly the right place? It's definitely something to think about.